In step 11, we're going to practice finding the slope and x and y intercepts of a line. Step 11 can kind of be divided into two sections, the slope section and the intercepts section. So I've chosen to record these into two separate videos so you can keep the topics separate and not get them too mixed up. Let's talk just about slope to start with. When we're talking about slope, we're talking about the steepness of a line. Think about ski slopes or roofs or staircases. All of these things can either be very steep or not very steep at all. It depends on their slope. It depends on how high up you go for every bit of distance you travel horizontally. So the slope can be defined as the ratio between the rise and the run. In other words, think about a coordinate graph. If we're going to rise and run, we're talking about changing on the y-axis, then changing on the x-axis. And when we do that, eventually, we get a nice line. How high up do I rise? How far do I run? How high up do I rise? How far do I run? And so on. It's kind of like counting the steps of a staircase. The slope can also be defined as the change in the y values over the change in the x values. Sometimes people even use the Greek symbol delta. Looks like a triangle. Delta y over delta x. That just means the same thing. Change means delta. Finally, we have a formula. The formula says that you subtract the y's and you subtract the x's, which makes sense. If I want to know how high up I go, I take this number of y and subtract from the number I started with, and that's the distance I've gone up. Similarly, I take this number and subtract with this number to figure out how far I've traveled horizontally. Let's practice finding slope from a line. First thing we want to do is pick two what we like to call really nice points on the line. There are a lot of points on this line. See how I'm marking them all in red? There's an infinite number of points, but there's only so many that are what we like to consider nice points. Nice points have integer coordinates. For instance, this point right here, and this point, or this point. All of these points have nice integer coordinates. For instance, the name of this point would be the point 0, 2. This point would be 1, 3. This point would be 2, 4. There's points back here in the negatives as well. We just want to find two nice points. Now I've kind of gone a bit overkill here. I found many nice points. So far I found 5, 6, and 7. We don't need 7 points. We only need 2 points. So you need to just pick 2 of your favorite. I'm going to start with these 2 points. I'm going to count how far up do I rise, which would be 1, and how far do I run, also 1. So my slope is 1 over 1, or I could just write 1. Either one would be correct. If a line goes up from left to right, the slope is going to be positive. Notice as I go along this line from the left to the right. I'm going up the graph, and my slope was a positive 1. Let's look at this next one. Again, I'm going to find 2 nice points. There are fewer nice integer coordinate points on this line. There's one right here. That's the point -3, 1. And there's a point right here at the center, at the origin, which we call 0, 0. If I start at my first point on the left, I have to go down 1, and I have to go over 1, 2, 3. Another way we write this is just -1/3. The negative can either be with the 1, it can be with the 3, or it can be shared between the 2 by putting it out front. If a line goes down from left to right, its slope is negative. So if I start on the left and follow the graph as it goes to the right, I'm going downhill. My slope is negative. Now, something people question, they say, well, what if I pick 2 different points? What's going to happen? Let's see what happens. What if I had picked this as my second point? That's the point 3, -1. I'm going to get rid of that original second point. Let's still count from the first point on the left to the next point on the right. I'm still going down 2, and I go over 1, 2, 3, 4, 5, 6 to the right. Down 2, 6 to the right. If I put that in the lowest terms, I still end up with -1/3. So no matter which points you choose, you will get the same slope of a linear function. It's nice to pick points that are closer together, like we did in the beginning, because then there's no reducing required. However, if you do, it's not a problem. It'll still work. Also, I want to discuss what happens if you start with this point on the right and go towards this point on the left. What if we start here? We'd have to go up 1, 2. So we're going up 2, so I'm making it a positive 2. And then I'd go back 1, 2, 3, 4, 5, 6. 6 to the left makes it a -6. It still reduces to be a -1/3. No matter how you try to count it, you will get the same exact answer. Sometimes we won't have a graph handy, so we can't just count the blocks between the points. Sometimes we're just going to have 2 points and their coordinates, and we want to have a handy formula to use to find the slope. This is the master formula right here. You see this formula if you Google the formula for slope, if you look in your textbook, if you ask any math teacher, they would tell you this is the formula for slope. There's a few parts that are very, very important with this formula. I want you to notice that they both have a minus, and it's a ratio. So when I focus on the slope formula, that's all I write. The minus on the top, the minus on the bottom, and a line to show that it's a ratio. I also begin by circling my y values. The most common mistake people make when calculating slope is they want to put the x values on top, and that's wrong. By circling the y values when you start, it's easy to remember, oh, I just circled them. I want to start with those. That's what I'm going to put into my formula. I'm going to put the 5 first, and I'm going to put the 13 next, which is actually different than what the formula suggested. We'll talk about that in a moment. Then on the bottom, I'm going to place my x values. Remember, this one was on the left and the right, so I'm going to do the same with my x values. Left, right, 2, 4. All that's left is to compute. 5 take away 13 is negative 8. 2 take away 4 is negative 2. That gives me a positive 4 for my slope. That's the answer. Now the formula here uses these little subscripts. It says y2 take away y1, x2 take away x1. Technically, you may have seen this before where you label each coordinate with these numbers, and you would do 13 take away 5 over 4 take away 2. That's fine. That's not wrong. However, it's been my experience that when people do it that way, sometimes they might start off doing 13 take away 5, but by the time they get down to the denominator, they forget to go back to the second point and they do 2 take away 4, and now the slope is wrong. So I encourage you to just put the line with the subtraction symbols, circle your y's, and drop them in the order you see them. 5, 13 over 2, 4. Just put them in and you will be less likely to mix up your slope formula. Let's practice. I'm going to draw a line with subtraction on the top and the bottom. I'm going to circle my y's and drop them into my formula. 5, negative 7. I'm not going to put a negative 7 right here because there's already a subtraction sign. When that happens, immediately cross it out. Negative 7. 5 take away negative 7 is just the same thing as 5 plus 7. Please stop writing negative, negative. Please stop writing take away a negative. You can't do two signs at once. You can only have one sign in between all of your numbers. So get in the habit of immediately taking this negative sign right here and using it to cancel out the negative that was already part of our formula. Because 5 plus 7 is 12. That's easy. That's a lot easier for your brain to handle than 5 minus negative 7. That's complicated. So we don't want to write it that way. On the bottom, I'm going to put my x values in. 3, 1. 3 take away 1 is just 2. And when I reduce, I get 6 over 1, or just 6. There's my slope formula. I'm going to circle the y's and drop them in. 5, 5. Then 3, 4. Now I'm going to do my arithmetic. 5 take away 5 is 0. 3 take away 4 is negative 1. 0 divided by anything is just 0. So that's my answer. Circle the y's, drop them in. 0, negative 2. 2, 5. As I put them into my formula, they look the same as they did when they were in the coordinate points. 0 plus 2 is 2. 2 take away 5 is negative 3. I can either leave this as my answer, or I can put the negative out front and change it to that. Either one is acceptable. Circle the y's. 2, negative 1, makes it become 2 plus 1. 4, take away 4. 2 plus 1 is just 3. 4 take away 4 is 0. This is a problem. We're not allowed to divide by 0. So we would say undefined. You may not divide by 0. That's very important to remember. So I made a note in my notes, and I invite you to do the same. Next, we will talk about x and y intercepts in our next video.